All right, we're back. We are on page 79, and we're talking about solving trig equations. And we've just seen that if we are given one of the trig functions that we're used to and a famous ratio, we can work them out basically in our head because we spent all that time getting the unit circle in our head. So we didn't have to use an inverse trig function at all because we just know sine of x equals 1/2. Where does that happen? It happens at pi over 6, 5 pi over 6. How do you know? You memorize that. Cosine is negative 1/2. That's going to be 2 pi over 3, 4 pi over 3. You memorized it. So by memorizing the unit circle, you actually memorize the solution to like an infinite number of trig equations, which is great. Just don't forget that you have to generalize them because you can keep going around the circle and you're going to keep hitting the same thing. Let's talk about less famous ratios. So I mean, here we go. Secant of x is equal to negative 5.234. I don't know. That's not a famous ratio that I'm aware of. In fact, most secants, I don't really know. Like two over radical 3. Do I even know what that is? I have no idea. So what we can do here, though, is we can take the ideas we were using before. We can draw a quadrant picture. So it's secant and it's negative, so it would be A, S, T, C. So anywhere cosine is negative, which will be quadrant 2, quadrant 3. Now I can find the reference angle because I know that if I take the absolute value of negative 5.234 and do the inverse secant of it, guaranteed I'm getting a quadrant 1 angle because inverse anything, inverse trig anything of a positive always gives you quadrant 1. Quadrant 1 angles are reference angles. So this is a really big deal. We're going to do for the reference angle, so I'm going to call it theta prime, I guess. No, x prime. So x, sometimes you use a little hat on top. I'm going to do that. X hat. That, you see it. I don't know, it happens. So my reference angle, x hat, is going to be the inverse secant of. So to emphasize this, I'm going to put it in absolute values, and I'm going to use a red for the absolute value thing. Okay, 5.234. In reality, you do not do that. In reality, you just write positive 5.234. But here I'm trying to really emphasize what we're doing. We're using the absolute value because, so the absolute value to I'm going to risk guarantee quadrant 1, therefore reference angle. So you're always going to use the absolute value. Like you just do it when you're finding reference angle. You're always using the absolute value. So no need to even belabor the point. If you're finding reference angle, it's going to be the inverse trig, whatever, of the absolute value of the ratio. So always doing inverse trig of a positive. You just don't want to get involved, right? We already did inverses. Inverses of negatives end up in weird places. Sometimes quadrant 4, but they're negative. Sometimes quadrant 2. We didn't even talk about inverse secant, cosecant, and cotangent because they don't really come up. So now what would my angles look like? Well, there's a quadrant 2 and a quadrant 3. So I'm just going to like divide them up here and say quadrant 2. So in quadrant 2, I know that what I want to do is I want to do pi minus the reference angle to get the actual angle. So everything that we've done is kind of like come together here. So I'm going to say that x is equal to pi minus the reference angle, which is the inverse secant of, and then I'm not going to be a weirdo, so I'm just going to write it. So that's in quadrant 2. And in quadrant 3, I know that if I have the reference angle and I want the actual angle, I have to do pi plus the reference angle. So x is pi plus the reference angle. I just got like worried there that I hadn't generalized, but that's not the step that I'm on right now, so that's okay. So pi plus the reference angle. So now the exact solution. So these are the angles, but I can keep going around the circle. So my actual final definitive answers here will be, you don't need to identify what quadrant the solution comes from, but I think it's helpful. I mean, it organizes your work, and then the person reading your work kind of loves you because you're so neat and organized. It's kind of nice to be loved. So maybe do it, I don't know if you're picking up what I'm saying here. So we get this, and then in quadrant 3, so here I'm just adding in the period which we could have done one step above, I suppose, but still kind of new to this, so why not 2 pi n is an element of the integers, so we get that. And now it says, what are the approximate solutions? All right, well, let's go to the calculator because that's the only way we're getting these. So I'm gonna go here and, all right, so one thing I can do, I can type in my answers, right? Pi minus the inverse secant, so I'm gonna do arc secant of 5.234 and press enter. So 1.763, and then I should really write 2 pi as a decimal because once you go decimals, it should all be decimals. So I'm gonna hand write this in right now. I'll go back to the notes at the end and kind of show you what they look like. So x is approximately 1.763 plus 6.283 n, where n is an element of the integers. And then we can do it again. So I'm going to say it's pi plus, so I can just do it right here. You can actually do it in one shot, plus, and then you can do plus 2 pi. Just make sure you say plus 2 pi times n, and then the calculator will do the work for you, right? So, oh, give me a decimal. So I get 4.520. So I'm going to write that. Some people don't write the extra 0 there, but I do because I like to just, you know, I'm like a train. I'm on the tracks. Like I can't deviate from what I do. So you're gonna get 3 decimals, 62, 6.283 n. So I'm writing this down here and there. All right. So another thing we could do is we could just ask the calculator to solve the equation. So I'm gonna do that. So what even is the equation? Solve. So this is weird. You might not have thought to do this, but you can. I mean, it's just an equation, and solve works on equations. Negative 5.234. The issue is, like, will it give you a weird form of it? Almost certainly, but let's find out. False. False. Negative secant definitely equals negative 5.234. Why are you telling me that's false? Can I get, all right, well, oh, inverse secant. What am I doing? That's why. It's inverse secant. Come on. Let me delete that. That never happened. All right. So one of these I think will be the same. 1.763. That we definitely got. The other one, again, giving us the negative, right? So I'm gonna take this, and then what can I do? I'm gonna do such that. So a weird way to get that bold 5 is to do at n5 equals 1. So it's just gonna substitute 1 for that bold n5, and it gives me 4.520, which is what we got. I would probably never do that on the handheld. I would probably actually have just gone in here and deleted the 5, and then just done such that, and then just use normal n. And now I'm getting all kinds of errors because I messed it up. But on the handheld, that would work if you had done it from like the first step. So I'm gonna do one more and then call it quits on this video. But the next one we're gonna do is kind of interesting, I think, because we got to remember something. And I'm confident that we will remember it because it's the most common mistake. Maybe I can't even get back though. If I can't get back, I'm gonna cut the video here. Okay, I cannot get back. So what I'm gonna do, I'm gonna maybe go back to the calculator for a second. I'll try one more time. Give me, unable to connect. Try again, get in there. Nope, can't do it. All right, you know what? I guess we are done, and I will be back in the next video, hopefully, to keep working on this. So I will see you there.